Thanks for sharing your lunch hour with us. We are very excited to be here to share our experiences in how we build serverless data masking pipelines at FINRA. My name is Geeta Ramachandran. I'm Director of Application Engineering at FINRA. I also have Lata.
Hi, welcome all. My name is Lata Nagaraj. I'm a Principal Application Architect at FINRA. I'm primarily responsible for delivery tools and products, and we are very excited because this is our first time presenting at reInvent. So Geeta will start the session. I will join a bit later to dive into more details of the solution.
Okay, let's get into today's agenda. We will begin with an introduction to FINRA, then set the context in terms of use cases and challenges in this space, and then dive deep into the solution. We'll look at the architecture of the solution and then see the solution in action in a demo. Finally, we will discuss metrics and the impact we saw in using the solution, and wrap up with future roadmap items and the open source projects. So what to expect from this session? We hope that you will learn about how FINRA enabled application teams to get a copy of production data in RDS through automation. We will be discussing some of the AWS serverless services that are used in the solution, such as step functions, Lambda, and Fargate. You will also learn about why data obfuscation is necessary and the considerations and best practices to keep in mind when implementing data obfuscation. Finally, we will discuss the security controls that are built into the solution to protect the sensitive data and to meet the needs of compliance. For those of you who don't know about FINRA, FINRA stands for Financial Industry Regulatory Authority. We regulate and monitor the brokerage industry and the stock markets in US. Our purpose is to protect investors and to promote market integrity. We want to ensure that the markets operate in a fair and orderly manner so that the investors feel safe and protected when they are investing their hard-earned money in the market. So we surveil the market events for fraud, insider trading, and manipulation, and then go after the wrongdoers. We oversee 99% of equities market and majority of options market. In terms of the volume that we deal with, we regulate 12 different stock market exchanges in US. We monitor 3,800 broker-dealer firms, and we oversee 634,000 broker-dealer representatives. FINRA is a big data processing company. We ingest up to 155 billion transactions in a single day. In doing so, we spin about 50,000 compute nodes to ingest and process this volume of data. When we reconstruct the market events for our surveillance needs to analyze the data, it gets to about trillions of edges and nodes that we need to look at and analyze. FINRA manages approximately 30 petabytes of data in storage. Overall, we have 150 different applications that are running in AWS that help us perform our regulatory functions. So let's set the context in terms of understanding why we need data masking pipelines. The primary purpose for data masking is when production data that has sensitive information, like PCI or PII, needs to be copied to another environment that is not as restricted, as controlled like production. So you might wonder, why do I need to copy production data to other environments? Let's look at some of the use cases that drive the need to have production data copied to lower environments. First, production data is required in research and analysis, where analysis functions would be to identify gaps in the data and normalize the data for any downstream services like ETL and analytics. Next, production data is highly useful in coming up with design strategies and implementation approach when designing an application or a solution. A major use case in production data is in testing, where the data is usually supplemented with test data in lower environments to validate a functionality of an application or measure the reliability of the infrastructure, or benchmark the performance of the system itself. Production data is also used in user acceptance testing. Having to test with production quality data in lower environments enables for early detection of issues and defects. Production data is also used in demo and training environments to train internal and external users. Finally, security is engaged throughout all of these use cases when the production data has to be copied and used in all of these different accounts or environments in a secure and compliant manner. So let's take a look at some of the challenges we face when implementing production data copy. In terms of security, the most critical aspect is how to handle sensitive data. The sensitivity of the data, depending on the type of the data set, we need to enforce compliance of certain regulations and policies to meet when copying that sensitive data to other environments. Also, the entire process have to be traceable and auditable in terms of who copied the data, when it got copied, and where it got copied to. Next, there are a set of operational challenges in terms of the data volume itself that needed to be copied, and the number of target environments that the data needed to be copied to. As we saw in use cases, we had multiple different environments that production data is required to be at, like analysis, development, testing, and training. So these are a set of operational challenges that we face when operationalizing production data copy. Finally, there are productivity-related challenges. In FINRA, we used to have a fairly manual process where the development teams would create tickets and requests to operations team and security team when they need to get a copy of production data. Now, these central teams would review these requests and go and execute certain semi-automated scripts in a manual way. The whole process takes about a few days. So the development teams cannot get their production data copied in a timely manner and a more frequent basis due to the lack of automation and also the whole turnaround time. So that's the challenge on the production team, on the development teams. Now, the central teams like operations and security teams also, they face challenges because they were not able to scale to meet the needs of multiple different development teams and also the volume of the data. So these are some of the challenges that we face when implementing and operationalizing production data copy. Since handling the sensitive data is the critical aspect of the challenge, and that's the core topic of our talk, let's dig deep into how to handle sensitive data challenge itself. The safest way to handle sensitive data is to not have it in the first place, right? Okay, so the goal is to obfuscate the sensitive data. What do I mean by data obfuscation? It is a process of sanitizing the data and anonymizing it to an extent where the data itself loses its original value or meaning at the end of obfuscation. Now, when we do this, we want to keep in mind that the structure and the format of the data itself is kept intact, so that any downstream application component or a database component that uses this data or consumes this data continues to work as expected. For example, if you have an account number field that has 6 digits, when you obfuscate, you want to retain the same 6 digit and only numerical fields. You do not want to create a 20 character of alphanumeric in that value, because that's going to break the database queries or the applications that are going to consume this data. So it's important to obfuscate, but also retain the structure and format of the data. So let's take a look at the overall data obfuscation process. The production data is in production AWS account, and you make a copy of this production data to a data staging environment in a data staging account. And then you run obfuscation on top of this copy to produce a final obfuscated copy in a target environment. Now, this can be copied over to any different environments or any different accounts like dev, test, or training. So the benefits of using data obfuscation is that the data is masked and obfuscated at rest so that it's following one of the security's best practice of not storing any sensitive information in lower environment, and hence it's reduced risk. Let's take a look at a slightly different approach, which you may have already heard about or even implemented in some of your projects, which is real-time data masking, where the data is masked in transit. Let's take a look at a typical workflow when you have real-time data masking. A user, when they request to view a sensitive information to the application would query that sensitive information from the database, and then based on the role of the user, it would go and mask that sensitive information and produce only a subset of that information masked back to the user. Now, note that the application has the logic of querying the user's role, and based on that role, running obfuscation or masking logic at runtime and producing the masked output in transit. Also note that the database that is storing the sensitive information has that intact, where the sensitive information is present and stored in the database. So think about when this database needs to be copied over to a lower environment. You still need to consider to have an obfuscation strategy in place when copying this data. Why? Because the same user roles that is available in production, the same user personas, may not exist in all of these different lower environments. Also, the access controls and the access management that are set in stone for the production account may not be exactly the same in all the lower environments. And typically, the lower environments are much less restricted compared to production. So even though you have a solution in place that does real-time data masking for your production environment, you need to have a solution in place to obfuscate the data at rest when copying it to lower environments. So with these challenges in mind, let's take a look at the solution that we have come up with that addresses these challenges and also to meet the requirements of the use cases. So I want to describe the design considerations that we kept in mind when we evaluated and before implementing the solution. The first key design consideration was to adopt a self-service model. This is to enable and make the development and the database admin teams to be more productive so that they will be able to leverage the solution and copy any data to any target account at any time. So copy any time and make it into a self-service model was one of our key design considerations. As with the flexibility of providing a self-service model and a copy anytime feature, it's very important for us to consider building in security controls into the solution itself, where the access management in terms of IAM roles or network access in terms of security groups, or even encrypting the database and the snapshots using KMS keys were very key design considerations that we had to keep in mind. Finally, the production data that needed to be desensitized is a critical aspect, and we chose to go with data obfuscation as our approach, which obfuscates the data at rest. As with any automation model, we want to make this into an end-to-end automation solution so that the development teams are able to integrate and use this solution into their existing workflow in terms of a one-click pipeline. Finally, the solution, we wanted to make it into a lightweight and a cost-efficient approach. Hence, we centered it around serverless services. So given these design considerations, the solution that we came up with is Maskopy. It's a data obfuscation framework. It obfuscates snapshots from production and copies to lower environments. It's built on top of AWS serverless services, such as step functions, Lambda, and Fargate. Maskopy's execution is driven by AWS step functions. Step functions is an orchestration service that allows you to coordinate multiple microservices based on visual workflows. Again, you can define these step functions as a state machine, so you have a lot of control and flexibility in place. Most of the components of Maskopy runs as Lambda functions. As many of you may already know, Lambda functions is a compute service that lets you to run code without having to manage the underlying servers. Finally, Maskopy uses AWS Fargate service to run the data obfuscation workloads. Fargate is very similar to Lambda. It's a container service that lets you to run containers without having to manage the infrastructure. If you have been to the keynote yesterday, Fargate has got a huge amount of attention. So we are in line with all of the serverless services that are provided from AWS. Let's take a look at the workflow using Maskopy. The data is in production account in terms of an RDS instance, and the data is stored in a snapshot. The developer or the development team who needs to get this data copied to a lower environment provides the data obfuscation scripts. And a SecOps admin, which is from a security team, would review these obfuscation scripts. And based on the review process, which is integrated in the workflow itself, the scripts are submitted to a Maskopy's automation pipeline, which runs in a data staging account or an environment, where Maskopy would take this production snapshot, creates a transient production snapshot copy, and runs the obfuscation scripts on the transient copy to produce an obfuscated snapshot. Now, this final obfuscated snapshot does not have any sensitive information like PCI or PII, and it is safe to share that obfuscated snapshot and copy to any target account or environment, like development, testing, and training. Once the snapshot is copied to these environments, now the Maskopy's automation pipeline can create a new RDS instance using that snapshot, or restore an existing RDS instance from this new snapshot. There we go. You already have the RDS instance with production data, but obfuscated, which is safe in all of these different accounts, and the development teams can start connecting to this database and start using this data to meet their needs. Let's take a look at the data obfuscation script on what the developer will provide. Here is an example data obfuscation script. It's a command line interface where it's making a call to a command called obfuscate_db, and it's connecting to a database whose name is parameterized, and it's obfuscating the column birth date on the table employee. It's also setting the email address to a test email address. Now, underneath the obfuscate command is making a call to a third-party vendor products API that we use internally to run obfuscation algorithms. Now, you can choose to bring your own algorithm implementation of obfuscation, and we are going to talk about some of the considerations to make in the rest of the session. Or you could use a pre-built tool or a vendor product that you might have at your enterprise. As we saw with data obfuscation, the whole solution and the process obfuscates the data at rest, and hence the reduced risk of low volume of sensitive data in storage in all the lower environments. Next, Lata is going to come up and talk about the architecture of the solution, and also give a deep dive on and walkthrough of all the solution's features.
Thank you, Geeta. That was a great way of setting the premise and leading the segue to architecture. So you would be learning about how we went through and thought about the architecture to meet the design requirements and challenges that Geeta was talking about. You'd also look at some of the data obfuscation principles, guiding principles that you can take away and apply when you're designing your obfuscation scripts. And finally, we'll see all this come together with a demo. So let's start by looking at what's on the production account. So as Geeta was showing you, it starts off by identifying the RDS instance and the corresponding snapshot, which could either be a manual snapshot or an automated snapshot that you intend to copy. And you could optionally also provide a parameter group. So parameter group is basically the one that determines the settings that you apply on your RDS instance. And you could choose to use the same settings when you're running your obfuscation scripts on the transient RDS instance. And finally, the most important one, your obfuscation scripts itself. So you would have this staged on S3, and it is expected that your application security team has reviewed it, and it is in accordance with the risk classification for your application. So you have all these input parameters, and once your SecOps approves the scripts, then your IAM roles get set up with access to execute Maskopy, which is a step function running on your data staging environment. So the IAM roles would do the authentication. They get the execute permissions. And Maskopy itself is implemented as a step function, which is weaving a lot of microservices. I will not get into the details of every minute step, but we will look at some of the main ones. So it starts off by authorizing the caller. So it's not sufficient that you just have execute permissions to kick off the step function. Maskopy still needs to make sure that the IAM role belongs to the application for which you're trying to copy the data. So authorization is done based upon the pre-signed URL of the calling IAM role. And once that is successful, Maskopy would use its own IAM role to copy the data from your production environment. So the application's IAM role do not have any direct access to copy any of the snapshots. They have to go through Maskopy, and Maskopy would do a assume role, and then it would copy based on the authorization. All right, so let's assume authorization is successful. The next step is it shares the production snapshot onto your data staging environment, and then it copies it and re-encrypts it with the KMS key belonging to the data staging environment. And this results in a transient re-encrypted snapshot. And now we are ready to restore a transient RDS instance from the snapshot. So up until now, we just set up the premise. We have all the setup that we need, and we are ready to kick off our obfuscation process. So our Fargate task kicks in. It pulls the obfuscation scripts from your S3 bucket. It pulls the obfuscation containers from your ECR, Elastic Container Registry, and it kicks off the obfuscation scripts on your transient RDS instance. So as you see, we use Lambda for most of our steps, but for running the obfuscation scripts, we are using a Fargate task. The reason being, the obfuscation scripts itself could run longer based upon the size of data you're trying to obfuscate, and Lambda has an upper limit of 15 minutes, the max execution time. So Fargate was a better choice, being a serverless containerized model for us to achieve the obfuscation goal. All right, so now we have obfuscation executed, and the RDS instance is now ready, and we take a final snapshot out of this, follow the same set of steps, we share it to the target account, copy it, and re-encrypt it with the KMS key belonging to the target account. And finally, an obfuscated snapshot is available on your target account. And once we are done with the entire process, we clean up all the transient resources like your RDS instance and your snapshot. So we make sure not to leave any trace of any production data on the data staging environment once we are done with the process. And then we send a notification on an SNS topic or an SQS queue, so that if you have any other downstream automation that needs to kick in after the obfuscation process is done, then it gives you a hook point to do that. All right, so the final step is once you have the obfuscated snapshot, you can bring up a new RDS instance on your target environment, and you're ready to go with any of your use cases, which could be either testing, development, analytics, and so on. And you also see that there's CloudWatch, which is capturing all the logs from your Lambda functions, your Fargate task, your obfuscation scripts, and it gives you complete visibility into what's going on in the step function. So with that said, I think the main takeaway would be if your organization is also operating in an agile mode where you need to deliver faster and you need to make production data available on a frequent basis to lower environments, then this setup would come in very handy and help you achieve those goals. So developers are happy because they are empowered now to kick off this copy whenever they need. Operations is happy, they don't have to deal with any tickets anymore. They don't have to do a manual copy or run any semi-automated scripts. And more importantly, they don't have to be a bottleneck in this entire process. And of course, application security is also happy because They would vet your scripts based on the risk classification once, and you can run your automation multiple times. They would review the scripts only if the risk classification changes or the structure of your data changes on your database. So with that said, I would like to zoom in a little more on the obfuscation containers. Let's look at how we have it structured in FINRA. So we have a FINRA compliant base image, which extends from the Amazon Linux image, and it has all security and compliance baked into it. It also comes with certain common tools, like maybe your Boto3 libraries, your credential management tools, log configurations, so on, which can be used by other application containers. And now your obfuscation container extends from this compliant base image, and you could bake in your own engine-specific clients, any third-party obfuscation tools, or any reusable obfuscation scripts itself. So we at FINRA have an image for Postgres and Oracle, but say if there's an application which needs something more beyond this, or it wants to bake in its own obfuscation tool that it wants to use, or it might be a different engine altogether, then you can bring in your own container as well. So you can bake in whatever you need into this container, either by extending the base image, or if you're not doing so, you still want to make sure that it is secure and compliant before you plug it into the ECR repository belonging to Maskopy. And once it is available in the ECR repository that Maskopy looks at, then it's the matter of providing this as an input parameter before you kick off your obfuscation process. And Maskopy would make sure that it runs your scripts against this container that you're provided. All right, so we looked at architecture, we looked at obfuscation containers. Now let's look at some of the design principles or considerations that you want to be mindful of when you're designing your scripts. The first one is you want to make sure that your obfuscation is irreversible. So what that means is if somebody gets access to the obfuscated data, they should not be able to revert back to the original sensitive data from this obfuscated data. So this makes sure that it protects your data on the lower environment so that even if there is anybody unauthorized getting access to it, they wouldn't be able to get back to the original sensitive information. The second one is de-identification. So de-identification is a process by which you protect the confidentiality of individuals. And the goal is to use techniques and methods which would minimize the risk of disclosing any of the identity-related information. So typically, or the best practice is to start by identifying certain parameters and classify them as direct identifiers and indirect identifiers. Direct identifiers could be like name or any ID associated with the individual. Indirect could be something like demographics or nationality, things like that. So based on the classification, then you can choose the appropriate techniques that you want to apply for obfuscation. The third one is referential integrity. So what this means is if you have a primary key which is getting obfuscated, you want to make sure that any references to this primary key, basically the foreign key references for this, are also obfuscated consistently in the same fashion. So this is not true just for within the same data source. It is true even for like heterogeneous data sources as well. So maintaining referential integrity is one important consideration. All right, so the fourth one is the algorithms itself. You want to make sure that this is industry standard algorithm, even better if it is NIST approved or recommended. And you also want to stay up to date with all the new emerging methods of obfuscation. The fourth one is FPE, which is popularly known as format preserving encryption. So this is where you would want to ensure that the obfuscated data retains the same structure and format as the original sensitive data, so that any downstream applications that are using this data are not broken and the format and the structure remains same. And finally, you want to still have the same realism of your production data, though you're replacing it with your fictional values. So this, in summary, are some guiding principles which we adhere to at FINRA, and you could use it as well in your scripts. Okay, so now let's see how we can have all this integrated in an automated pipeline. So we use Jenkins for our CI/CD requirements, but if you have any other platform, you should still be able to do the same thing in a similar way. So let's look at what happens in our pipelines. So we start by pulling the scripts from our source code repository, archiving it, and staging it on S3. And this is assumed to be, or this is expected to be security approved, and the scripts are staged once on the S3 bucket. Then the Maskopy automation kicks off, which is running on your data staging environment, and it uses the input parameters of your production snapshot that you intend to copy, and various other, and the target accounts that you want it to copy to. And then the other two stages kick in, wherein you're refreshing your RDS instance on your dev or on your any other lower environment from this obfuscated snapshot. So the way I have it set up here is it's sequential, so dev is happening first and then going to test, but that need not be the case. You could refresh multiple of your lower environments in parallel once the obfuscated snapshot is available. So you could run these pipelines on demand as and when you need data, or you could schedule it to run on a frequent basis so that you're in sync with production data on maybe a weekly basis or any time period that you choose. All right, so now let's look at all this in action. I really wish I could show you a live demo, but this entire process takes quite some time. So I have a recorded demo, and I will try my level best to match my commentary with what you see. Let's start. Okay, so we start off by looking at the production RDS. I'm here on the production account, and this is my RDS instance. So let's go to maintenance and backup and look at what snapshots I got. So I'm going to pick the one that I want to copy over. So I see that there's one manual snapshot that was taken. So let's use that to copy over. I would want to also look at what configuration exists on my RDS instance. Basically the parameter group and the options group. So this is an Oracle engine. So it's using the default options group and a default parameter group. So I'll use the same when I'm running the obfuscation. And let's look at how I can connect to this. Okay, so this is my endpoint and this is my port. All right, so we have the connection details. I mean, this is a fictional prod database. Obviously, you won't be able to connect to a prod instance like this. Okay, so here I am connecting to my prod fictional database. And let's now look at what's it got. So it's got a simple, just one table, just for demo purposes. And it has certain fields. It's got like legal name, account number, and so on. Let's look at what's the data in there and what fields do we really care about to obfuscate. So I'm firing off my select query here. Okay, so let's assume that based on my risk classification, legal name, account number, and birth date are sensitive, and I want to obfuscate those. So assuming so, let's look at how my script would shape up. So it's a simple shell script, which is using a third-party obfuscation tool, which is wrapped in that script. And I'm calling I'm obfuscating the individual table. I'm specifying the column that I want to do, and I'm saying it needs to be non-reversible. And similarly, I am obfuscating the other two columns as well. So now I have my script ready. The next step is I need to submit it for review to application security. So here I've submitted a PR, and let's assume Geeta is from application security. She has reviewed it and she has approved it. Once she approves it, I'm good to merge it. So I go ahead and merge my PR, and here I am ready with my scripts and ready to kick off my automation pipeline. So let's look at the pipeline. It's a simple pipeline. It starts with the first card, which is triggering Maskopy, and then subsequent parallel steps, which is going to restore from dev and restore on QA environment. So let's kick it off. So I'm providing the snapshot identifier from the prod account, which I need to copy. Then I'm providing, I could optionally give a name on the target account if I want to name that snapshot differently. And I'm also giving the options group and the parameter group, and providing the path where I want to stage my scripts and the target account that I want to copy it to. So now I'm going to kick off the pipeline. So here at this point, it is grabbing the scripts from my source code repository, making sure that it is reviewed and approved by appropriate security admins. And then it is calling the Maskopy step function on the data staging environment. So this would take quite some time to finish. Now let's see if we can go to the data staging environment and look at the step function that got triggered. So this is, I'm on the console for the data staging account. Okay, all right, I see execution kicked off. Do is my application name, so it prefixed it with my application name and with a timestamp. And here I am, my step function running, and it's already past the authorization phase, and it is now trying to share and copy the snapshot onto the data staging environment. So now, once this finishes, we should be able to go to the snapshots view on my data staging environment and be able to look at the transient snapshot that is getting copied from the production environment. So let's move on to the console again. So here I am on the snapshots view, and you see that the transient snapshot is available now. So this is still not obfuscated. This still has the production data. It's a transient copy. Now we are ready to kick off a restore from this snapshot. So it kicked off restore DB snapshot step. Now let's go back and see what's going on the RDS side. So you see that a transient RDS instance is getting created from the snapshot. Yeah, so this would take a few minutes to come up and be available. So the step function would wait for the RDS instance to be available. And once it's available, then it's going to kick off your Fargate task. All right, so it's running the Fargate task. Now let's go back to the cluster and see what's running on that Fargate cluster. So here I am. Let's go to the tasks. We should see that there is a task that got kicked off. All right, so it's running my obfuscation task. And yeah, so once the task is successful, it will go ahead with the remaining steps, which is going to be taking a snapshot from this RDS instance and sharing it to your target environments. All right, so this would, and it also sends out appropriate notifications. So this is the final obfuscated snapshot that is going to be shared on the target account. So it's getting created at this point. So as we saw, it could be multiple target accounts too, and it will start sharing it in parallel to different target accounts. So that was it. It completed. The step function is fine. We have everything done. And now let's, the next step in the pipeline gets kicked in, which is basically restoring from this snapshot that copied on your lower environments. So the restore got kicked in. So it could be like you bringing up a new instance altogether, or you could restore on an existing RDS instance as well. So this again would take some time to be restored and to be available. Okay, so now we have the lower environment RDS instance. Let's log into that and see if we really have the obfuscated data. So this is my dev environment, the same table, same fields. Let's look at what's in there. So I'm going to fire off my select query. And yeah, we should definitely see obfuscated data over there. Yep, so there you see it has obfuscated all the 3 fields that we looked at. And we are now ready to go, be it for any of the use cases. So that covers the demo. I know it was a little high speed, but yeah, the recording will be available so you can watch it later on too. So let's moving back to the presentation. So just to re-emphasize some of the security controls that were seamlessly fitted into this automation, we saw the IAM roles, which is used to authenticate and authorize the caller. And also we saw that application IAM roles would not have any direct access to any of your production snapshots or RDS instance. They have to go through Maskopy if they want to copy any of the data. So we have IAM roles protecting with authentication and authorization. The second one is we are also protecting at the network layer. So the transient RDS instance, which is getting created on the data staging account, has security group applied on it, which acts as a virtual firewall rule and only allows inbound access from the Fargate task, the Maskopy's obfuscation task. Applications wouldn't be able to connect directly to it. There's no inbound rule from any of the applications. Next, we saw that the security team would approve the obfuscation scripts based on the risk categorization, and the pipeline execution is also indirectly authorized by your SecOps admin because it checks whether the approvals are in place before kicking off the automation. The fourth one is credentials. So any user accounts or application accounts that exist on your production snapshot will be reset by Maskopy when it is making a copy onto your target accounts. So none of these credentials would get passed on as is to any of your lower environments. And also the application roles do not have access to any of the master credential that will be used when you're launching your transient RDS instance. And finally, the RDS itself is encrypted using KMS key, and this is the KMS key belonging to the account and region. So that's the reason when we copied cross account, we re-encrypt it with the KMS key of the specific target account. So this is in summary the 5 security controls we have in place. And then the operations and governance aspect. So there's complete auditability because your pipelines have a trace of who executed the copy, by who approved it, when was it done. So there's a complete audit trail of when a certain production data was copied. And there is complete traceability in terms of CloudWatch logs, which gives you insights into the specific details of what happened. And also the step function execution history gives you details, a visual detail of all the different steps that were executed. And the last one is all this is centrally managed in a data staging account, and only obfuscated data gets out of this account. So it is easy to manage and lean. So with that, I will call over Geeta here. She is going to walk you through some metrics and also discuss about certain future roadmap items that we have.
Thanks, Lata. That was an awesome demo and a great walkthrough of all the features that Maskopy offers. Don't you agree? Yeah. Thank you. Let's take a look at some of the metrics we saw since we deployed the solution in FINRA accounts. After we deployed the service as a centrally managed solution, many application teams started to onboard to the solution and started using it for their daily needs. So the total number of executions in the last few months for Maskopy rose to about more than 200 times. The max volume of data that Maskopy copied and obfuscated in a single execution was about 1,500 gigs of database size. Finally, the overall turnaround time for Maskopy solution itself was in few hours compared to days previously. So this allowed us to scale to meet the needs of multiple different development teams and also multiple different database types. So in terms of impact that we saw in using the solution across the enterprise, first, it's cost efficient. As you saw in the architecture and the demo, almost all the resources that Maskopy either created or was running from were all short-lived, and all the transient resources gets cleaned up at the end of the execution, irrespective of whether the execution was successful or was failure. And also, there are no long-running servers. So just to give an example for the overall cost of running Maskopy on an average size database, let's say 500 gigs, the cost was about $1. Where the cost for running the step functions, Lambda or Fargate, was extremely minimal in terms of like 0.005 cents, and majority of the cost went in creating the transient RDS resources like the transient RDS instance and the snapshot. Next, in terms of operations, because Maskopy runs as serverless, you do not have to manage any servers that runs Maskopy itself. So there are no AMI upgrades or maintenance for patching and compliance that you need to manage. And Maskopy is deployed as a centralized server. So if your application team from your enterprise wants to take advantage of the solution, they do not have to consider an installation or a deployment or maintenance of that solution itself to meet their needs. All they need to do is onboard to the solution and start using it. Next, pluggability. Because Maskopy runs as step functions, you could pretty much plug into any AWS service that step functions integrates to, like SNS, SQS, or as recently announced like last week, EMRs. The next aspect for Maskopy is bringing your own obfuscation container. And we designed it that way because we wanted to give the flexibility to the development teams to be able to consider their risk classification of the data and have them bake their own tool sets or their own frameworks or strategies, bake it into a container, and bring that into the obfuscation solution. So it's pretty much a data obfuscation tool agnostic solution. Future looks very exciting for us. As you see, the current Maskopy looks at the RDS instances. And as we are looking to move to serverless type databases like Aurora RDS and DynamoDB, we wanted to extend the support for Maskopy to leverage data coming from these database services as well. Next, as Lata mentioned about the security controls that are built into the solution, we wanted to bring in an observability or a mode of visualization of how these security controls are operating within the solution so that you get a single pane of view in terms of all of these security controls in action. Next, the exciting part. Super thrilled to announce that Maskopy is open sourced. If you go to GitHub, in FINRA OS/Maskopy, it's available as an open source project. So whatever we covered throughout in this session is already available to you to go check out and see if it makes sense to adopt this in your organization and to meet your data masking needs. This provides a great deal of documentation in terms of getting started and also how to set up your AWS accounts in terms of the roles, security groups, and all the dependencies. Maskopy can be easily deployed by a single-click CloudFormation deployment. So you have these CloudFormation templates that you can take and go and deploy it into your organization's environments and accounts. So please go check out and watch this GitHub space for our new updates and new releases that we make. So not just Maskopy, we have got quite a few other FINRA's open source projects that are available in GitHub. So if you go to technology.finra.org/open source, you'll be able to see a lot of our products that are available. And I'm going to list out some of our DevOps tools and product suites that we have already available. Maskopy is the first one that we just saw in this session. Next, we have Gatekeeper. Gatekeeper allows temporary access to EC2 instances and RDS. So if you have to troubleshoot an issue, you need to have temporary credentials to get onto the instance to troubleshoot. It's very easy. And it is automatic expiration of all this access, which is completely auditable. Next, we have Yum Nginx API, which is a tool written in Go to upload RPM packages to Yum. And then Aphelion is a tool to monitor AWS service limits so that you can proactively go and ask for limit increases when you reach a threshold. Fidelius is a secrets management solution in AWS.
Yeah, in addition to what Geeta already walked you through, we have a lot of other products in the pipeline to be open sourced. So the first one is CloudPass, which helps you get temporary token access to get onto any of the AWS accounts. Then we have Portus, which is going to help you with the security group management. It helps security teams to define the policies for your rules and empowers developers to create security groups based on these policies. And finally, we have Provision, which helps you create resources on AWS in compliant with certain standards that you would have been wanting for your organization. So with that, I think we would like to summarize our session, and some key takeaways would be if your organization is also on a similar journey as that of FINRA's, where you have a need to make your production data available to your lower environments on a frequent basis, then the solution that we discussed should help you leap forward in that direction and provide you a complete end-to-end automation.
Along with end-to-end automation, there is a huge benefit of giving productivity gain to your teams, which are development teams, operations, and security teams, along with security guardrails pre-built into the solution itself. And all of this is achieved in a lean, cost-efficient, and a lightweight solution. With that, you can go check out some of the training and certification tracks in security itself. And we would like to thank you thanks a lot for your participation in this session. And we'll be right outside to take any questions. Thank you.
Thank you.